I was asked to originally join the panel. The last second, they asked whether or not I would be willing to present a topic. So I threw an idea out there, and this is what I'll be talking about, which is essentially defining the telco cloud. So for those of you who don't know, my name is Marco Rodrigues. I work for Juniper Network specifically in the Open Contrail business unit. So we primarily focus on a open source based SDN solution. Not just for OpenStack. OpenStack obviously for a lot of our telco customers, but we have an SDN solution that pretty much goes across the entire gamut. We have container-based production deployments. We have in-house orchestration systems, custom built using Contrail as well. So it's a fairly robust networking solution used pretty much across SaaS, PaaS, telco, enterprises, IT as a service, you name it. So the way I was thinking about this session was a lot of people get right into the details of why telcos are building clouds or trying to build a telco cloud. I'm trying to take it a step back in the sense that I'm trying to define the why, because there's a very fundamental reason why telcos are trying to do what they are doing. And I think it gets lost on a lot of people. All the activities are actually a great thing in terms of what's happening, but you have to kind of, from an OpenStack point of view, being predominantly enterprise before telcos started using OpenStack more predominantly, there's a reason for that, right? It isn't just because they fixated on something. So I'm going to focus on the why they're focused on it so much. Then try to define some parameters, very high level. I was literally told don't make this a product pitch, so other than Juniper logo at the bottom right-hand corner, there is literally no reference to any products whatsoever. Just idea, thinking. That's how I like to keep it, nice and clean. So the second topic is what is a telco cloud in terms of trying to define some requirements around it. Third, telco cloud requirements. This is where we start to see a little bit of friction around what traditionally enterprise customers and workloads were demanding versus what telcos are demanding. So I try to define the delta there and what's been done recently, and more importantly, what work needs to be done moving forward. And then I try to nail down, or drill down rather, on a specific use case. I picked mobile just because it's probably the more relevant use case I find in most telcos as we engage with. But by no means is it the only one. So why the telco cloud? Well, let's first state the obvious. The current state of affairs in terms of IP transport, it's been commoditized. And there's nothing wrong with that. Actually, that's a result of success in a lot of ways, right? It's happened throughout the ages, right? Specifically, Industrial Revolution. The idea is, steel gave way to certain industries. Same with petrol, oil, right? But the byproduct of oil was petrol. So industries tend to build on industries, and things get commoditized, and that's the nature of business. So when you're a successful business, you're commoditized. Unfortunately, with commoditization, the investments tend to follow as well. So what the telcos are actually feeling is a pressure point when it comes to money coming in from users and consumers towards these large entities. And the challenge, of course, is CapEx spend's not going away. If anything, it's probably going up because demand is growing so much. So you have this divergence now of this massive growth in CapEx because there's this massive growth in usage of a platform, essentially the internet, by these guys, the cloud, and ultimately the consumers, the OTT players, and they need to deal with it. So, taking into account, just looking at the economics of growth, right? If you actually look at networking, I'd say in the last 14 years, those are some pretty big numbers in terms of growth, right? It's actually quite incredible if you look at the growth curve, if you actually were to plot that. But the real challenge, of course, is they as in telcos are having a tremendous problem trying to monetize this still, right? They did for many years, and they continue to do so, but it's getting harder and harder, especially as capacity is just growing exponentially on the network. And hardware, networks aren't getting cheaper to run, right? Especially last mile networks that are literally the infrastructure and lifeblood of industries, everything finance to hospitals to governments, etc. So Still focusing on why the telco cloud. I call this the value stack. If you kind of go through the ages, you probably heard me mention it before earlier during the panel discussions, is people are only willing to pay for what they consume. Reality is I'm willing to pay Netflix a certain amount of money per month because that's the content I consume. I could care less about what network is running over on top until it breaks, right? But again, that's just the nature of business, right? People, it's all about the value you can present to people as in the consumers, both being residential and business, and more importantly, what they're willing to pay for it. So literally, if you go through the ages, right, most telcos historically have always been at the top of this value stack. This is what they consumed, right? So back in the early 19th century, the fact that you can actually pick up a phone and call someone, I was like, wow, that was the experience, right? That was the consumption. Go through the ages. These dates obviously aren't accurate. I'm sure someone can go on Wikipedia and correct me in an instant. But that's not the point. The point I'm trying to illustrate here, of course, is the fact that over time, essentially, what you're noticing is this trend of consumption always happening at the top of the stack. That's actually very natural because the consumers come from top down. But what's kind of happening, or actually not kind of, but what actually has already happened, I'd say probably somewhere in the mid 2005-ish to 2010, and you're seeing it really hyper accelerate now today, is services and content, SaaS, and centralized platforms, so essentially all the massive cloud guys, they're the consumers now, right? Or meaning they're the platforms. That's what people love to use, and that's where a lot of the money's flowing to. So telcos really have to kind of reinvent themselves. How do they, in a lot of ways, they used to be pretty much all the way up until here. They're kind of in no man's land here in some form or another. So to me, the telco cloud is all about reinserting themselves in this stack, right? It's can you find some way to provide value, not only to the SaaS, PaaS, and app owners, to their customers, which ultimately are the ones who consume, provide value in that way. And by no means is this not a reason, by no means does it mean telcos can't run over the top and provide services as well, but the real focus is trying to make sure we narrow down on what it is telcos have, right? And I mentioned it before, is they have beachfront property, right, which is hundreds of years of infrastructure built out. They have to leverage it somehow. So I'll get into the details later on how they can do that and why that differentiates their cloud environment. So in terms of what's next, right? Had a friend make this up for me a little while ago. Anyways, there's two main themes. I won't focus on the first one. More focused on the second one specifically for this talk. But the first one is total cost of ownership, which is it should be pretty obvious, is reducing CapEx and OpEx. That's a given, right? Any company over time, as they grow, they need to eventually shrink as they become more focused and specialize in their skill set. And that's actually a normal business cycle problem, right? Companies just get big and they need to deal with that over time. So that's an OpEx issue. How do you deal with that? Reskill the workforce, automates certain things, et cetera. And but again, all that does is streamline a business. And if all you want to do is provide a very good commoditized, streamlined service or utility, then that's fine. But the reality is, no business ever wants to be that. If they can actually create new services, new revenue streams, that's always what not only businesses want, but the market wants. So the real second focus of what's next for telcos is building new revenue streams. And that's where I try to pivot and show how a telco cloud itself can be a mechanism for essentially telcos or MSOs, cable operators, whomever, people who have physical infrastructure can leverage that. So I'll touch on this briefly. I mentioned it's not the focus of this talk, but I think it's overlooked quite a bit, and I know Brian was speaking to it earlier. I'm a big fan of OpenConfig. I think that's probably the best way of streamlining and automating not only how you provision different elements in your network. I think you should even go up the stack higher. You should have open config data models which actually clearly define how you program certain services, whether it's a layer 3 VPN attachment, a bare metal type integration. That's the holy grail, right? And that's how you really get to true environment that you can streamline OpEx costs by lowering them And by streamlining OpEx, you can really get true automation. And when you get true automation, what can you do? You can adopt new technology faster. So you can actually ride the technology curve much quicker. So when there's new advances in silicon or whatever to reduce cost, cost per bit essentially, you can do that without taking a 4 to 5 year cycle of just trying to get stuff in the network. Essentially, what you've probably heard referred to in the industry in some form or another called the waterfall effect. The idea, of course, is define a set of data models and clearly some APIs. There's a lot, the industry's pretty much converged on the Yang as a mechanism and NetConf as the delivery, but that just everyone's agreed on English, the syntax. Everyone really needs to agree what a paragraph structure looks like, right? Once everyone agrees on that, then you can focus on rock solid implementations, differentiate in the actual implementations and the differentiation there, not being locked into a certain vendor based on the fact that they have certain ways of configuring stuff and your whole OSS stack is kind of keyed in off of that. So again, this is not the focus of this presentation, but I think this is a very critical component which probably deserves its whole entire separate presentation. So, so to focus on how you want to build new revenue streams. So again, this very high level, right? This is how you tend to see centralized public and even private clouds. Don't have to explain all these different layers. I mean, it should be common knowledge for most people in this room. But the reality is there is differentiation in distributed cloud. And what I mean by that is there's some inherent properties that you get with that. So as workloads run on a distributed platform, what are those properties? So one of them is sheer physical distribution. So what does that mean? With physical distribution, you naturally get high availability. That's just the way things work, right? I mean, if you want to have an application that's running in a very large-scale data center and then there's some large internet disruption somewhere, by distributing stuff closer to eyeballs, depending on the criticality of that application, you naturally get HA without having even to do anything. It's distributed by nature. So having a distributed cloud automatically gives you that. Low latency. There's going to be a myriad of low latency applications, I think, that's going to be coming with less AR, more VR type technologies. There's, God help us, remote surgeries done by robots by a doctor sitting on a beach somewhere. You want to make sure latency is not going to be an issue when he's performing a surgery on you, right? I mean, and there will obviously be software and tools that help the process, but there's going to be applications, no matter what, at the end of the day, is going to require some type of low latency, so that'll require workloads to be pushed closer to the edge. High availability, I mentioned. Network traffic optimization. So what do I mean by that? Perfect case, so this is where, in terms of the value chain, right? So look at HBO Go, or say you even want a new History Channel, right? I guess, is it Disney that owns them? Say me as a consumer of HBO Go, I love Games of Thrones. I'm willing to pay for 4K. I'm willing to pay HBO Go an extra $2 a month so I can stream 4K content because I'm a big fan of the show. Now, what is HBO's alternatives, right? They can either increase network capacity to pretty much every eyeball provider out there, which costs them a lot of money, takes a lot of time. And by no means they have to do it anyways, but the question is, how can they get new experiences to the customers quicker? So I signed up for a 4K streaming service to HBO Go, and I pay them $2 a month because they know every Sunday night at this specific time I'm going to consume it. So it's a time-based optimization as well. So what happens now is, now I'm paying HBO Go this extra $2 a month for 4K content for Game of Thrones. What they can now do is, without actually increasing capacity in their network, they can actually average it out better, do better planning, and more importantly, they can push content into the eyeball networks closer to whoever wants to consume them. So the value there now is, think of it as almost CDN as a service, right? There's always been this battle with the content guys, the Akamai's of the world, the Netflixes of the world, and then the eyeball companies, where they're like, let us put, oh, there was a question? Sorry? They're paying for backhaul, but the carrier at some, so HBO, for example, has either level 3 or some transit provider. It's also a challenge for the HBO Go or Netflix is probably a better example with their Open Connect model. Well, two people have to pay for it, right? The content provider and their interconnects. Okay, so no. But what I'm saying is HBO has a transit provider. But what happens when they want to overnight flip their services from 1K to 4K? They got to increase capacities to that backbone provider. So that's a cost for HBO. Correct. That increases the capacity from the carriers to the backbone providers, not necessarily HBO. But so to finish through the workflow is, what happens if HBO now is able to beam 4K content ahead of time to pretty much a cache sitting right by an eyeball, or kind of think of it like a mini data center closest to me ahead of time. And the value there, of course, is I'm consuming 4K content. Traffic doesn't have to, network capacity doesn't have to grow based on the service requirements, not right away at least. Bingo. So there's a monetization happening from the user point of view. I'm happy. I'm consuming Game of Thrones and its gory content in 4K detail. I'm paying HBO $2 a month. HBO will probably kick back a certain amount of money to, a telco's infrastructure at a couple of cents, per hour, whatever. It doesn't matter, whatever the economics is. But that's the kind of what I mean by network traffic optimization. You can now size the network differently. And even if I'm a network, so not even HBO, or at the end of the day, if I have good content and I want to be able to do this and reach eyeballs more effectively, I can do that as well. It doesn't have to just be HBO and Netflix. They just kind of they tend to be the big use cases, right, or Hulu's. That's kind of what I mean. That's another value prop of a distributed cloud. You get inherent access to eyeballs. Oh, and the value for the telcos is users now have an incentive to be on that network. If I had a choice of a last mile provider, say between AT&T and say Time Warner down in Texas, and I know for a fact that with Time Warner I can't get 4K streaming like HBO offers, or let me take that back. They'll probably at the end of the day try to still push 4K, but now there's a less likelihood of my experience being worse, so it's probably in their best interest not to do it, versus they can always promote that AT&T has this enhanced cloud infrastructure that will ensure my experience, so I'm going to choose between a last mile provider who gives me a better experience. So there's a retention aspect of this as well. It's all about enhancing, it's all about enhancing the value based on the inherent properties of your cloud to keep users who consume the content, or anything for that matter. I can. That's a big issue, right? OTTs think they don't have to pay for anything, but. Yep. So that you're talking about, I don't want to diverge too much, but is it transcoding to provide effective delivery on their network? So that's very popular in mobile, right? For example, T-Mobile is a perfect example, right? I forget what they call it, binge on or something. The reality is, when you agree to give me unlimited streaming of Netflix, T-Mobile for free, reality is they throw you probably to a bunch of HTTPS proxies, and that's all it is. Sorry, media proxies, and they just transcode it to a lower thing, and boom, right, and you're done. And less consumption on the network, users are happy, they get to consume the hell out of anything for free. 480p you can't tell the difference of 480p. Yeah, we can whiteboard it, or, white pen it on. I was tempted to just pull this up and start drawing. So again, what the hell is it? Okay, I guess. Key properties: physical distribution, resources close to eyeballs for both consumers and business. So that was a consumer use case. There's always going to be value for businesses as well. A lot of SD-WAN providers who are going over the top providing enterprise services, if they can come to an enterprise and say, look, because of this distributed cloud infrastructure, I can provide a better high availability, or I can provide better tooling, or a better experience for your enterprise. Are you willing to pay me an extra $5 a month? Enterprise X will say yes. And then SD-WAN provider says, all right, well, I need to make sure your last mile providers gives me this distributed infrastructure because it's inherent to how I plan to deliver my service to you. So it's not consumers, it's business. But again, this assumes that telcos are open-minded in the sense that they let anyone run the workloads on their network. but that's where I think the most of the money is going to come from, the new revenue streams. It'll take time to get there, I think. So low latency is important, high availability, high volume of last throughput. That's just kind of a long-winded way of saying what I just tried to explain. And then I think another key component is seamless integration of essentially existing infrastructures and operational awareness. Not awareness, but existing practices and procedures. You always, the biggest issue with adopting any new technology is the barrier to entry for a skill set that's existed for a decade or two to a new skill set, right? And people that scares the hell out of a lot of people. So that combined with the fact that you have an existing infrastructure that you want to leverage, right? Telcos are not greenfield. They are brownfield by nature. They never will be greenfield. So from a telco cloud point of view, you have to define a certain set of key technologies in any cloud environment, distributed cloud environment, that will easily meld with their existing infrastructure. That's key, right? That's table stakes in my view. So I call them connectivity building blocks. I'll put these slides on SlideShare, and whoever wants, you can grab them if you want. Is there a question? Or just hissing at me? Okay. So these are all technologies that are predominantly very heavily used in telco networks. To me, table stakes for any SD-WAN solution for a telco cloud network should inherently implement all this. But honestly, it all depends on the conversation I'm having. This goes back to the point I was talking about bridging gaps. When I go to network guys at a telco, they love all this gory details, right? They just love to talk about this technology. You go to an IT guy, enterprise, Riot Games, because they're like, I could care less about this, right? Just tell me how I can get this spun up, this connected here between a private and public cloud and scale it out and make sure it's integrated to Mesos or something like that, right? The beauty of all that, of course, is this is just implementation details, which allows people to engage with telcos, to bridge the gap this way towards IT and enterprise and kind of application-like thinking, and then you got the reverse direction happening as well. And all this should really be wrapped around something that's well understood. To Juniper, at least, as part of our open contrail solution or project, we make sure there's full feature parity with Neutron where the features exist, and Neutron extensions where the features exist. There's still a huge superset of features that the platform offers that we provide direct API access to, and our policy is as Neutron catches up, API-wise, we make sure the implementation in our backend fully integrates with that. And the value of there is Neutron now, or our SDN solution or open contrail solution, will always fit in the OpenStack framework as long as the APIs are well defined and understood by other components. We don't want to break stuff, essentially. So I live in Texas, so I just picked Texas map. That's kind of the high-level view of really what should be happening, right? In terms of where the end goal is, right? And again, these little things, just think of them right down to the CL level. You may have some level of x86 compute, right? And just don't think about wire. I think that the game changer is wireless. Yep. It's where I'm working for a networking vendor. I just still get I think I'm sick of acronyms, names, technologies. Yes, but I think they call it MEC now, mobile edge computing. Just call it what it is, right? So when I hear 5G, they call it network slicing. There's all these. At the end of the day, people have their different terminology. Fundamentally, it's always this. There's always a fundamental technology that kind of is the same, right?